I equals mx plus b, f of x equals mx plus b. So it's just a notation that you have to be familiar with. Okay? X, m, and b are real numbers, and the graph of f of x equal to y equals mx plus b is a line with a slope of m and a y-intercept of b. You know this already, it's just going to come in a different form. So watch up here. If this says f of 1 equals 2, what coordinate pair is this giving you? When you put in 1 for x, you get out. So what you want to write to the side here is that the coordinate point 1, 2 is on your line. Input, domain, output, range. So what's the other point? 2, 5. And now you can all take it from here, I would hope. How do you calculate the slope between 2 points? Do you remember? Good. Change in y over x, right? So Marquina, we subtract the y's, and we get 3. And Swabi, 2 minus 1 on the x's? So what's my slope?
3.
Look familiar?
Yes.
So this is old news, something you've done, but under the heading of function notation. So you need to now know that this would be how you pull off the coordinate points, okay? The notation is just different. Do we know the y-intercept? No, but so far we have y equals 3x plus b. How can we find b? Pick one. You pick. What do you want? First one. Awesome. Plug in 2 for y, 1 for x. We solve for b. Okay? So she picked this point. We'll go with it. 2 equals 3 plus b. B equals -1. Put it all together. I'm not going to use y anymore. I almost wrote it, right? I'm going to use f of x equals 3x minus 1. All right? I know we're moving quickly. You're going to get it. Next one. M equals -3/2. So what are they giving you in this one that's nice? They're giving you the slope. Now listen. F of 0 equals -1/2. What coordinate point is that?
Oh.
0, comma, -1/2. Input, output. Why is this a nice point that they just gave you? What's that?
You know the equation?
What is it?
Y.
Not y.
F of x
F of x
equals -3/2 x plus 1/2 plus
not plus 1/2.
minus.
-1/2. Very good. So actually, less work involved with that one because they just gave you the 2 pieces that you needed, just in a different form. Okay? So again, what's the big message, guys? You know linear work. You've done slope, you've done intercepts, but now it's just in the form of this function notation. All right, let's see what's going on the next page. Did they give you the slope? Are they giving you the slope in number 3?
No.
No. What are they giving you?
Y.
Coordinates.
Coordinates. Go ahead. Let's get this done now. We've got 2 different input and output scenarios. Pull them apart. 6, 7, 3, 2. The challenge with this one is they're not just asking for the equation, they're actually asking for a couple of outputs. You know, what's going to happen when we plug in -3 and what's going to happen if you plug in 10? Being that these 2 inputs are on this same line. So we got a little work to do. Okay, we got to figure out the equation, and then we got to do a little math. All right, so let's get the slope first. Here we go. Let's get the slope between these 2 points. So Marquina, you're going this way, 2 minus 5. Excuse me, 2 minus 7.
Yeah.
So negative 5 over,
Negative
which reduces to
5.
positive 5/3. There's our slope. Y equals 5/3 x plus b. Were they nice in giving us the y-intercept on this one? No, we got to do some work. Pick a point. Do you want 3, 2 or 6, 7? I want 3, 2 because I'm looking at this and I'm thinking I think I can cancel with the denominator, and that's what's going to happen. So y is 2, x is 3. We're going to plug in to get b. Okay? 3's cancel. 2 equals 5 plus b. B equals negative 3. So let's put our equation together. Not y, but f of x equals, what's the slope?
5/3.
5/3 x minus 3. And now let's answer the question. F of negative 3. So what are we going to plug in for x? Negative 3. 5 over 3. Don't be afraid of fractions. What happens to the 3's?
Cancel out. Kind of.
Don't forget that negative right there, right? Kind of. Negative 5 minus 3. Negative 8. So f of negative 3 gives us negative 8. Input, output, but you had to get the equation first before you could answer that. Not only do we have to plug in negative 3, but we must also plug in 10. So I'm going to just do it over here. F of 10, let's go. 5/3 times 10 minus 3. Any canceling going on? Multiply. 50 over 3 minus 3 over 1, but get a common denominator and make 3 over 1. Common denominator? 9 over 3. Thank you. Right? Final answer, f of 10 equals 40 over 3. Not as friendly of a number, but hey, not all things are going to come out nice and easy, right? Okay? But that works. All right, friends, we're almost done. Let's just do a couple applications. Real world situations for functions. Linear functions. Again, this should look familiar. Erin, nice and loud, read what's going on in example 1.
A new computer is purchased for $3,600 and loses $600 in value each year. Write a function that models the situation without the table, then graph it below.
Good. Hey, by the way, it's not just f of x. You can call it whatever the heck you want. Since it represents a computer, I'm going to call it c of x. Okay? It means the same exact thing. G of x, h of x, k of x. It's all just function notation. All right, we're starting at $3,600. So over time, if it's times 0, how much is the computer worth? $3,600. That's just the very beginning. It hasn't lost any value, but after 1 year, how much value is it going to lose?
600.
So we're down to what?
3,000.
And then? Oh wait, 20, right, we skipped a year, right? I go to 3 years, huh? So let's,
1,900.
good, John, 1,800. But before we finish the table, I'm going to see if you guys can see something. All right? What does that losing $600 represent?
The cost.
The cost going down every year. Very good. And that constant rate of loss. So what does it mean mathematically, thinking linear? It's your slope. And is it a positive slope or a negative slope? So would you all agree that this is negative 600x plus your y-intercept or your initial value, $3,600. Should have done something similar to this when you worked with lines back in December, when you did them in 516, remembering how things lost value or gained value. All right? So now, if I'm kind of sick of subtracting myself, what can I plug in for x?
6203. Joe, please call 6203.
5, right? 5 for x. So what do I get when I plug in 5 times 600? How much? 600 bucks, good. And then we plug in 6, what happens?
0.
Done. All right? So what I'd like you guys to do is go ahead and do a quick graph of this. Okay? Noting that as each year passes, this thing is losing value and it's losing value fast. So just to get a good scale, go by 600s on your y. Just to get yourself some room enough to graph it. Again, maybe we'd give you a better fitted graph just to make sure it all works, but it's here, 3,600. And how long does it take to lose all its value? 6 years. Now, Swabi, am I going to draw my line anywhere except the first quadrant?
No.
Like, should I extend my...
0 for 1.
Exactly, right? We can't just continue to go down. 0, it's zeroed out, we're done. Okay? Alright? So again, the real only difference for most of you guys is this idea that we're putting it into function form. Domain, range. Which, by the way, just to add to this real quick, what do your domain values go between? 0 and 6. So just a quick reference point, that's something you might do next year in 512, is that you would have to show me that you understand between what? As high as? But as low as 0. So just a little something to add to that as sort of your set restriction. Alright? Alright guys, last page, or is there? Oh, that was it. Okay? Please stick around guys if you have any questions. I know we move kind of fast, it's just kind of getting you the information. Mr. Rooney, is there anything I need to...